Hey, what's up, Gomez gang? Today we're going to talk about scale factors within scale drawings, and hopefully we can close some content gaps there. On this problem, I have given you two rectangles that are scale drawings of one another, rectangle A and rectangle B. Rectangle A has dimensions of 4 centimeters by 3 centimeters, and we are going to try and find the dimensions of rectangle B when given the scale drawing or scale factor of 3. When I have a scale factor of 3, I am multiplying all of my side lengths by 3. In other words, my length of 4 centimeters will be multiplied by 3 in order to get me to 12 centimeters. My width of 3 centimeters is going to be multiplied by 3 in order to get me to 9 centimeters. The original area of rectangle A was 4 centimeters multiplied by 3 centimeters, which gets me to 12 centimeters squared. And for rectangle B, we are doing 12 centimeters multiplied by 9 centimeters, which will get me an area of 108 centimeters squared. Now, although we do have a scale factor of 3, our areas did not change by multiplied by 3. They multiplied by a slightly different number. That number is 9. In a slightly different problem, I'm going to give you the area for rectangle B. And if I tell you that the area of rectangle B is 48 centimeters squared, I am trying to determine what the scale factor is. That is what my question is asking. Someone might look at this and say, hey, my area is going from 12 centimeters squared to 48 centimeters squared, so there must be a scale factor of 4. However, that is not the case. Although, yes, area of rectangle A is being multiplied by 4, that does not mean that I have a scale factor of 4. If I were to try that out, I know that, like I said, my side lengths are the ones that have to be multiplied by the scale factor. So that 4 centimeters is going to be multiplied by 4 in order to get to 16 centimeters. My 3 centimeter width has to be multiplied by 4 in order to get to my width of rectangle B, which will get me to 12 centimeters. As we know, 16 centimeters multiplied by 12 centimeters will not get me to 48 centimeters. It will get me to 192 centimeters squared, which is why you are not scaling the areas. That is a shortcut that will not get you to the correct answer. For our final problem, we're going to talk about getting a scale factor when given both areas. In this situation, we have rectangle B's areas listed as 300 centimeters squared. Firstly, we can determine that to get from the area of rectangle A to the rectangle B's area, you need to multiply by 25. Now, as we mentioned in the previous figure, that does not mean that that is the scale factor. We need to understand what we are multiplying our side lengths by in rectangle A to get to a rectangle B. You may have noticed that to get to times 25, you can do multiplying it by 5 and then followed by multiplying it by 5. In other words, multiplying by 5 twice. If I multiply each one of my side lengths by 5, we'll get to 20 centimeters on this side and 15 centimeters for my width in rectangle B. 20 times 15 will get me to that 300 centimeters, which is why our scale factor, in fact, is 5 and not times 25.